Good morning students, welcome to Konnur online classes. Here, previous classes we can discussing some important concept, that is event. Here event is event means it is a subset of sample space. Here on the basis of that some terms are given here. Take one example, that is a die is rolled. A die is a roll. Here we get a sample space, that is 1, 2, 3, 4, 5, 6. Here a die is a roll. That's an experiment. A die is rolled. That is experiment. Outcomes, that is 1, 2, here. A die is rolled. A die is rolled. A die is rolled. That is considered one experiment. Outcomes, here 1, 2, 3, 4, 5, 6. Here these are the outcomes. Event means here take another one is a sample space. Sample space means set of all possible outcomes of a random experiment. Random experiments, here random experiment is a die is rolled. Possible outcomes is 1, 2, 3, 4, 5, 6. Sample space means it is a collection of a set of all possible outcomes of that random experiment. That is 1, 2, 3, 4, 5, then 6. Here sample space. Then according to event. Event is the subset of a sample space. Consider one event, that is odd numbers will occur, even numbers occur. Take one even. One event is even number occurs. 2, 4, 6. Even numbers will occur. Take another one is E2. Here E2 is odd number will be occurs. 1, 3, 5. Here these are the two events. Null event means more than 6 numbers will occur. There is no possibility. Then there is a null set. Then sure event means it is sure event is equal to sample space. That is S equal to 1, 2, 3, 4, 5, then 6. Then simple event, consider 1 will be occurring. Here even 1. Here are even prime number will be occurring. That is 2. Here these are the simple event. Compound event, that is these two are the compound event. Even number will be occurring and odd number will be occurring. These are the compound events. Then here even equal to even number will be occurring. 2, 4, 6. Odd number will be occurring. E2 1, 3, 5. Definitely even intersection of E2 is equal to null set. That implies even and E2 belongs to that concept. Even and E2 are mutually exclusive events. Similarly, consider an event even, that is odd number. Even number will be 2, 4, 6. Here, then second one is E2. Odd number will be occurring. That is 1, 3, 5. Here, even union of E2 is equal to 1, 2, 3, 4, 5, 6. 5, then 6. Here even union of E2 is equal to 1, 2, 3, 4, 5, 6. Definitely it is we get a sample space. space. Therefore, E1 and E2 are exhaustive events. Exhaustive events. Here, on the basis of take one experiment, we can define correspondence terms. Here, an experiment is a die is rolled. A die is rolled. Possible outcome 1, 2, 3, 4, 5. The set of all possible possible outcomes of that experiment is called sample space. Here, set of 1, 2, 3, 4, 5 are called sample space. Then, event is a subset of sample space. Consider even number will be occurring is one event, odd number will be occurring another event. Then more than here sample space containing 1 to 6 number, more than 6 number, it is not possible to mention. That's why it's a null event. Then sure event is definitely is equal to sample space. Then simple event, here consider even a prime number, that is definitely 2 will become belonging to 1, 2, 3, 4, 5, 6. That is a simple event. Compound event, even number will be occurring or odd number will be occurring. That is a compound events. Then consider these two events, E1 and E2. Here E1 and E2 are the two events corresponding these two events. Intersection of E1 and E2 we get null set. Therefore E1 and E2 are mutually exclusive, and intersection of these two E1 and E2 we get the sample space. That's why E1 and E2 are called exhaustive events. Here take an important definition, probability of an event. Here consider one event A. Probability of that event is definitely the ratio of number of favorable outcomes. The ratio of number of favorable outcomes to the total number of outcomes. Here is a definition of probability of an event. Probability of an event. Probability of an event is the ratio of number of favorable outcomes. Number of favorable outcomes to the total number of possible outcomes. That is, here probability of an event P of A is equal to number of favorable outcomes divided by total number of outcomes. Here this is the definition of probability of an event. On the basis of this definition we can take these two examples. Here find the probability of getting head through a coin. Here a coin is thrown. This is the one experiment. A coin is thrown. A single coin is thrown. This is the one experiment. Here in this experiment, possible result, they are called possible result. They are called head or tail. Here set of these two events are called sample space. Sample space. Here there are total possible outcomes are head and tail. They are totally two possible result. Totally two possible result. Find the probability of getting a head. Getting head is one event. Here event getting head. Here only head occurring only one time, that is H is equal to 0, 1. Here probability of this event E is equal to favorable outcomes. Here number of favorable outcomes are 0, 1. Here number of favorable outcomes is 0, 1 divided by total number of outcomes is 2. Here 1 by 2 is the probability of this event. Here find the probability of getting head through a coin. Here, throw a coin is our one experiment. A coin is tossed one time. Here it's an experiment. The possible result head or tail. There are two possible. Total outcomes are two. Getting head is only one head will be occurring one time tossing a coin. Here probability of this event, number of favorable outcomes divided by total number of outcomes. Here number of favorable outcome is 1 and total outcome is 2. That's why probability of this event is 1 by 2. Here consider next one is an unbiased die is rolled. An unbiased die is rolled. Find the probability of first one getting a multiple of 3, getting a prime number. Here an experiment containing getting a die is rolled. Possible outcomes are 1, 2, 3, 4, 5, 6. Here these are the total 6 possible outcomes. Here on the basis of these terms, getting a multiple of 3, getting a multiple of 3. Here this is the event 1 is getting a multiple of 3 are 3 and 6 are the getting a multiple of 3 belongs to this sample space. That's why there are two favorable outcomes. Probability of this event, probability of even is equal to 2 divided by 6. Here favorable outcome is 2, total possible outcomes are 6. Here 1 by 3 is our probability of this event. Here similarly consider another event E2, that is getting a prime number. Here prime number are 2, 3 and 5. These are the prime number belonging to 1, 3, 1, 2, 3, 4, 5, 6. Here there are 3 possible outcomes, favorable outcomes, and total outcomes are 6. That's why probability of this event E2 is equal to 3 divided by 6. Here 1 by 2 is our answer. Take another important example is a die is rolled. A die is rolled. Let E be the event. A die is rolled. E be the event. Die shows 4. And F be the event. Die shows even number. Or E and F are mutually exclusive. Here this is one. A die is rolled. Experiment is die is rolled. Here die is rolled. We get sample space means 1, 2, 3, 4, 5, 6. Even and event E, that is E. Die shows a number 4. Die shows a number 4. And F be the event. F be the event. Here F is the event. Die shows even number. Even number, that is 2, 4, 6. In this question, are E and F are mutually exclusive. Then here mutually exclusive means E1 and E2 are the two events. Consider E1 and E2 are the two events. Intersection of these two events we get null set. Then E1 and E2 are called mutually exclusive. Here in this case E intersection of F we get 4 intersection of 2, 4, 6. Then E intersection of F is equal to 4. Therefore, which is not equal to null set. E and F is not equal to null set. Therefore, E and F are not a mutually exclusive events.